Physical Science Exam 2015, question 12. A solar cell converts one form of energy to another. What energy change is occurring? Well, a solar cell, what are solar cells? There you've got them on the roof. They convert sunlight, so they're going to convert light energy. And you can plug those straight into your battery or your television or your PlayStation or whatever. It's going to convert that straight into electrical. Okay. Name a device that converts sound energy into electrical energy. Not actually strictly on the syllabus, but nonetheless. So you take sound energy, energy that's emitting from, say, for instance, I'm using one right now. My sound is being emitted, it's being saved as electrical energy, well, it's being converted into electrical energy so that this can all be saved and you can hear it later on. It's going to be called a microphone. There's probably other examples, but that's the one that springs to mind at the moment. Describe the energy conversion associated with a person stretching a rubber band. Okay, so if you're stretching a rubber band, haven't actually got a rubber band, be good if I did, but what you're doing there is you're converting the chemical energy from your food, I guess. It depends how far you want to start back, but there's the chemical energy is converting into kinetic energy of the movement of your muscles. So we'll start with kinetic energy. Kinetic energy from muscles to go to elastic, sorry. What sort of energy? If you're stretching a spring, it's stretched and you let it go, bang, it's going to come back electrical potential energy. Energy. There'll also be a little bit of heat in there. Okay, a supermarket worker wheels a trolley containing a 7.5 kilogram box 5 meters along a level floor at a constant speed of 2 meters per second. How much work does the worker do, ignore any frictional forces? So there's no if there's no frictional forces, then there's no force required to keep the trolley moving, so they're moving at a constant velocity. If they're moving at a constant velocity, so there's no work done in that case. The worker now lifts the box onto a shelf 1.50 meters high. How much work is done? Supermarket, let's say that they've lifted at 1.5 meters, so they've stopped. They're lifting at 1.5, so the work done, if we have a look at our information sheet, you can see this down here. Work is equal to the force times displacement. Now the displacement is 1.5. Work done equals Fs. The S is equal to 1.50 meters. But what is the force done? The force, well, working the force is against gravity. Force is equal to the mass times gravity, and we know that gravity is 9.81 meters per second squared down. So force is equal to m times g, which equals, the mass is 7.50 times 9.81. So what we have here is equal to the m times g times s, which equals 7.50 times 9.81 times 1.50. Trusty calculator. 7.5 times 9.81 times 1.5 equals 110. Let us say that's close enough to 110 joules of energy. Very good. Is that the end of the story? Yes, it is.